There's the alligator clip with the high tension lead. That's going to be your high tension spark.
Okay.
So if you were testing a coil, you would use this. This would go in the coil tower. So the high voltage would go through here and you would see it physically jump across there. Or if it was a small engine coil, it would go where the spark plug lead.
Okay, so you're still using the engine to turn...
Nope, coil's in your hand.
Oh, okay.
Coil's in your hand. This is, you're testing components on a bench here.
Okay.
All right. Then you have your basic on and off switch with a little glow light. Okay, standby, nothing's happening.
Okay.
All right, so then you have the ability to test the condenser, and this will give you condenser leakage, and it will give you series resistance using the two small leads, the red and the black.
Okay.
Black obviously is the ground, red goes to the lead, and you just simply bring over condenser, and this is going to test it for leakage. What's going to happen on a good condenser, you would see the meter go up and go down. And then you can test the capacity, and then coming over here, you'll be able to load the condenser. So that's the condenser test side, still using these. Now you go over to the coil side, you have secondary continuity, primary continuity. So secondary continuity is going to be from the tower, the center tower, to the positive, and then the primary is going to be negative, positive on the coil.
Okay, and generally speaking, either
You're
power
using
off...
power's off, coil's in your hand, or if it's in the car, everything's shut off. But that would be the same as if you used an ohm meter today to test a coil. Then the polarity, it just gives you positive, negative, so you know the polarity. Now the coil index and the coil test, that's unique to this. You bring it down to a coil index, and this knob increases or decreases the amount of power or voltage going into a coil. So there was a book with this. You might find something online from the Graham people, if they're still, the guy's probably not in business anymore. At any rate, when you're testing a coil, I found pointing at 12 o'clock was a good starting point.
Okay. Now you were testing mostly small one-cylinder, two-cylinder engines?
Or like a Coil engine uses just a regular Delco 12-volt ignition coil.
Okay. Do you know if it was like 1.5 ohm coil, 3 ohm coil?
1.5 ohm coils.
Okay.
And a lot of them had a resistor built in them as well, so you could run 12 volts right to them. At any rate, to test the coil, you simply connect the leads to the red lead going to the lead on the coil that would go to the condenser, or on a 12 volt or 6 volt coil, it would be positive, negative terminals. And then you would put this into the center of the coil, or the spark plug lead. If it was a small engine coil, you put it in a spark plug lead. Then the index, when the thing is on and you have this connected, it will give you a number up in here. This will sweep back and forth, and since there's no coil hooked up to it, it's not going to do that. Then the coil test goes over here, and this is your momentary on and off coil switch. It's spring loaded here. See, if you let go of it, it goes over. What that does is it sends the voltage through the coil, and now the spark would come out here.
Okay.
So, for example, if you could get the coil to spark at a very low number, 12 o'clock being top, 6 o'clock being down here. So if it were sparking with a continuous spark that you see across here at a 9 o'clock, 10 o'clock position, it's a really good coil.
Okay.
Or if you had to go way up over to here to, say, 2 or 3 o'clock, then you're putting an awful lot of power into the coil. Then your series resistance and your primary resistance based on the coil would probably be bad.
Now, when you say based on the coil, is it coil type, or is it coil ohm rating? Or
the coil ohm rating, yeah. So if you get into a book, or if there's a general rule of thumb, 1.5 ohms, 3 ohms, whatever it might be, if there's a general rule of thumb, that's what you would be using on your primary and secondary continuity, because there is actually, when you start looking at this, there's primary continuity in ohms, secondary continuity in ohms, but it's a different, see the ohms, the secondary goes to 100,000, and then series resistance in ohms, so there's, and then capacity for your coils in microfarads, that's on your condensers. So you play around with that, and you'll see in the top one is coil index, starting from 0 going up to 100, and that's turned by this.
Okay. So this this machine tests coils, and then did you say it tests other items as well?
Coils, any kind of a 12 volt, 6 volt coil that you would have on a car or tractors or whatever, which the same business, and any point system ignition used on small engines.
Okay.
Or chainsaws, lawnmowers, anything that's not a CD. So it has points, the points, condenser, and the coil can be tested on that. Then there's one other thing that was added, because we worked with this character at Graham. He was an older gentleman a long time ago when CD ignitions started becoming more popular, particularly in our chainsaw stuff. We had no way of testing it. Solid state.
So, okay, CD is...
Capacitor discharge.
Oh, okay.
Or pointsless.
Okay.
We had no way of testing them.
Okay.
Because typically if you didn't have spark, you had a spark tester, not a spark plug, but a tester on the high tension lead, and you would just simply unplug the kill switch, make sure that that wire from the kill switch to the coil wasn't grounded. If you had no spark, you threw it away. Well, in our position, we needed to test stuff. So he came up with this, and this is an add-on which has nothing to do with it, and I left it on there.
What?
This is a CD pack.
What is that?
It is a electromagnet.
Oh, cool. Okay.
Okay, so the object of this is that you hook up a coil, and you're basically taking a CD unit and you're hooking it up with this high tension lead into where the spark plug would go.
Okay.
And you're attaching your ground and a red lead, and then you take this, you turn this on, and you hold the CD unit and you wave this back and forth on the metal core that the magnets of the flywheel go past to generate a flux or current to make it work. So that's used only if you were checking a CD unit on a small engine.
Okay.
So that may, I just left it on there. You can do whatever you want.
Okay.
That's what that is. So you turn off the switch and everything goes wrong. This, there's nothing hooked up to this amplifier. That again was something that was an experiment with this guy and our stuff to try and make a tester, and then of course things evolved from there. So that's the long and the short of it.
Okay, sounds good. And your name again?
Kirby.
Kirby.
Settings on the main control knob to adjust it to 0 when you have the two leads put together here, so that you get a 0 ohm reading when you put it together.
Okay.
So there is also an adjustment on the meter, but the meter adjustment is not for power. It's when it's at rest, so that the meter thing here should be at 0. That's what this is for. On the back side, these all are marked and they adjust for series of resistance and so forth to 0 it in when you have the two leads together.
How often would you check this? I mean, would it be once a week, or just if you felt that it was off, kind of thing?
Yeah, I guess. Well, let's take a look. Let's put it on primary continuity. Okay, so you see it's right up to 0 over here on this side. When I turn it off, you see it goes back over to 0. And secondary continuity is 0'd again. And then series resistance, see, that's a little bit low.
Okay.
Now be careful. These could be. You see, that does move
a little resistance.
Yeah, there could be some. It hasn't been used in a long time, so see, it gets a little bit. Now it's getting closer. So you got to be careful with that. But that's what those knobs are on the back side. And then, if you want to look at all of the tubes and whatnot, they're inside there. But it's pretty simple.
Nice. Thank you.
da 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 da.